going to finish our review of trigonometry today. It's part 3 of 3. And what I will say is this is the least important of the 3 days. Probably the main thing you would need to know is actually this first row here, the graph of y equals sine x, cos x, and tan x. You should be familiar with that. The rest of the stuff, it might pop up very rarely. So, it's good to know, but not nearly as important as what we've done in the other reviews. So you'll notice what I've done here is I've put a whole bunch of points, the same points on each one of the graphs, just so I don't have to draw them on all every time and draw out this video. So you might want to start by doing that. And what we're going to do is we're going to remind you what the different graphs look like for sine, cos, tan, which shouldn't be too bad. And then these ones, which are a little bit harder, the reciprocal functions. So for the sine graph and cos graph, remember that it has maximum of 1 and minimum of -1. So I'll put those in there as well. And I'm not going to spend a lot of time deriving it because you should be at the point where you basically have memorized this. Remember that there's 5 key points. When x is 0, the sine graph is equal to 0. Sine 0 equals 0. Sine pi over 2 is 1. Sine pi is 0. Sine 3 pi over 2 is -1. And sine 2 pi is 0 again. And that's one complete period right there. So it goes up, comes down, goes up, and of course it continues, right? And it also continues this way. So at negative pi over 2, it would be at -1. So this is your sine graph. Now for your cos graph, it's very similar, except it starts, when we draw it, we usually start at x equals 0, 1. Cosine of 0 is 1. And then at pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, it's back at 0. And at 2 pi, it's up to 1. This is one complete period. Again, of course, it continues, and we continue out this way. At negative pi over 2, it's back down at 0. So that's our graph for the cosine. For the tan graph, remember that tan is equal to sine over cos. So you can't have cos equaling 0. That would make it undefined, and you'd have a vertical asymptote there. So where does cosine equal 0? Well, it equals 0 here at negative pi over 2. So we know we're going to have a vertical asymptote there. It also equals 0 at pi over 2. So vertical asymptote there. And at 3 pi over 2. Those are our vertical asymptotes. Now, whenever we have sine equaling 0, then the tan graph will equal 0, because 0 divided by something is 0. So where does sine equal 0? Sine equals 0 at x equals 0. So put one there, a dot there. Sine equals 0 at pi, so I can put a dot there. And sine equals 0 at 2 pi, so I can put a dot there. And then what you'll need to remember is that kind of the snakes and electric fences. So here's my snake, and it's squished between the electric fences, which is the asymptotes. So remember this is what your tan graph looks like. We spent more time with it in pre-calc 12, so I'm not going to go through a lot of detail about all this. And over here would look something like that. Now for the reciprocal graphs, we're going to look at the primary trigonometric ratios, the graphs for those, and we're going to do the reciprocal. So again, what you would want to look at here is for cosecant, remember that cosecant is 1 over sine. You'd want to look at when does sine equal 0, because you can't have it equal 0. There'd have to be a vertical asymptote there. So sine equals 0 when x equals 0, vertical asymptote right here. Sine equals 0 at pi, vertical asymptote right here. Sine equals 0 at 2 pi, vertical asymptote right here. Now, key points are when sine equals 1. How come? Because reciprocal of 1 is 1. It just stays the same. So at pi over 2 for sine, the y value is 1, and the reciprocal of 1 is 1. So at pi over 2, it's still 1. -1, the reciprocal of -1 is also -1. So wherever the sine graph is equal to -1, like at negative pi over 2, it's also going to be -1 for the cosecant graph. Again, the reason for that is because the reciprocal of -1 is still -1. So right here at 3 pi over 2, it should be at -1. Now, what happens as these numbers get lower and lower and lower here, closer to 0? When you take a reciprocal of smaller and smaller and smaller numbers, you know what happens? They get bigger and bigger and bigger. And same here, as these numbers get lower and lower and lower, these ones get bigger and bigger and bigger. Same here, as these numbers get smaller and smaller negatives, you'll get bigger and bigger negatives. And same here, smaller and smaller negatives, bigger and bigger negatives. And the same sort of thing over here. Okay, you're going to have the same sort of thing over here. This is secant graph, which is 1 over cosine. Where does cosine equal 0? Right here at negative pi over 2, at pi over 2, and at 3 pi over 2. So we're going to have vertical asymptotes there because you can't divide by 0. Where does cosine equal 1? Right here. Reciprocal of 1 is still 1. Also equals 1 here at 2 pi. Reciprocal of 1 is still 1, so you're going to have a point there. Where does it equal negative 1? Right here at pi. So negative 1, the reciprocal is still negative 1. Same sort of thing. As these numbers get smaller and smaller and smaller, these ones are getting bigger and bigger and bigger. Smaller and smaller means bigger and bigger for reciprocal. Small and smaller negative means bigger and bigger negative. Same here. I think you get the idea now. This is your secant graph. Cotan, well, cotan's 1 over tan, so where does tan equal 0? Tan equals 0 when x is 0, so you can't be taking the reciprocal of 0, so you have to have a vertical asymptote there at pi and at 2 pi. Now, where you have the vertical asymptotes here, that means you effectively would have been dividing by 0 here. So when you take the reciprocal of undefined, what do you get? 0. So wherever there's an asymptote here, it has y equals 0 value here. So 3 pi over 2, and where's my other one? Negative pi over 2. Now, if you look really close to here, you have very small numbers. If you're taking the reciprocal of small numbers, you're having huge numbers. And then the numbers are getting bigger and bigger and bigger, which means the numbers here, the reciprocal, are getting smaller and smaller and smaller. Same here. Here we have a very, very big negative number. Well, that would mean a very, very small negative number when you take the reciprocal. And then you're getting very, very small negative numbers, which ends up having very, very big negative numbers. You end up having the snakes again, the snakes and electrical wires, but this time they're going the other direction. And those are your graphs for the 6 trigonometric ratios. Now, the ones I said are most important are the top row here, so make sure you're really familiar with those ones. Okay, next question. We're going to write an equation in the form y equals a sine b, x minus c plus d, and also y equals a cos b, x minus c plus d, for the smallest non-negative real number c with a is positive and b is positive for this graph. It says following graphs, but it should say graph. That's a lot of information here. So basically you need to know what A, B, C, and D is in these equations here in order to solve it. I'm actually going to write it in a different order. I'm going to put dab C. We all love dabbing, unless you've forgotten what dabbing is, which is hard to believe that young people would ever forget how to dab. Okay, D. D is how much the graph is shifted up or down. So the key here is to find the midline. Wherever the midline is, that's what your D value is. So here's our lowest point at -2, our minimum, our maximum's at 4. Midpoint's right in the middle of -2 and 4. You know how to find that? You could either just kind of look and figure it out, or you can add those two numbers together, 4, -2, it gives you 2, and then divide by 2, average them out. So the average is at 1. This is our midpoint right here. And that means if that's the midpoint, that's also the D value. Our D value is 1. Okay, A is amplitude, so that's the distance from the midpoint to the maximum or from the midpoint to the minimum. And it's a distance, so it always is positive. So 1, 2, 3, or if you want, 1, 2, 3. Your A value is 3. To get the B value, you need to use the formula for period. Remember that period equals, for sine and cosine graphs, that's what we're dealing with here, it's 2 pi over the absolute value of b. So what we want to know is what's the period? Okay, well let's take a look here. Let's pick a point. How about this point right there? And where's the next time we have that exact point? This is the point where the graph increases after it reaches the midpoint. So here's the midpoint, but it's decreasing. Here, midpoint, it's increasing. Whatever the distance is from there to there, that's the period. But here's the problem. We have nothing written here to tell us how much that distance is. Well, it does tell us it's pi here. How many steps did it take to get to pi? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It took 12 steps to get to pi. If that's the case, where are we right here? We're at 1/12 of the way, or pi over 12. Now, I'm not going to write them all, but next would be 2 pi over 12. I think I should write this one because these are our 5 key points here, right? These ones right here, 1, 2, 3, 4, 5 are really key points. So pi over 12, or 1 pi over 12, 2 pi over 12, 3 pi over 12, which is the same as pi over 4, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12, 9 pi over 12. I'm actually going to write 9 pi over 12 here. I know it's not in lowest terms. I'll write lowest terms below it, 3 pi over 4, right? Now, why did I write that like that? Because now I can figure out the distance from this point to this point. Pi over 12, or 1 pi over 12 to 9 pi over 12. What's the different distance between them? 8 pi over 12. So our period is equal to 8 pi over 12. Oh, 8 pi over 12 we can put in lowest terms. It's 2 pi over 3, and that has to be equal to 2 pi over the absolute value of b. Well, look, if it's 2 pi over 3 equals 2 pi over b, what must b be equal to? In order to make those two things exactly the same, b has to be equal to 3. So we found our b value. It's 3. Now, we're going to leave the c value for a second. What I'm going to do is I'm going to write these two equations right here. I'm going to fill in everything we know so far. So for the sine graph, we have y equals a. Well, a is 3. Sine b, b is 3. X minus c, I'll just put x minus, plus d, and d is 1. And then for the cosine, I do exactly the same thing. Y equals a, well, a is 3, just like before. Cosine b, that's 3 as well, x minus, plus d, and d is 1. So the only thing that's going to be different between the sine and the cosine graph is this number right here, that c value. How do you figure that one out? Well, you look for what's the smallest possible phase shift, or horizontal translation, in order for this to be a sine graph. Remember that sine graphs always start at the midline and go up. So where do we have this the first time it's at the midline going up? That would be right here. You'll notice this is also the midline going up, but they asked us specifically to pick the smallest one. So it's this first one over here we're interested in. So how much is it shifted over here? Instead of starting right at the y-axis, it's been shifted over pi over 12. So that's your value that you're plugging in right here, pi over 12. And if you're confused by the minus sign, remember when we do transformations, a negative sign in here means it's actually a shift to the right, and that's exactly what we have there. Okay, for the cosine, I have to remember that a cosine graph starts at a maximum and goes down. So where's the first time you see that, a maximum and goes down? I see it right here. You could say this one as well, and you could put that number in, and it would be right, except it says the smallest. So you have to put this number in, which is pi over 4. So that's your answer for your phase shift here, pi over 4. Phase shift, remember, is exactly the same as a horizontal translation. Okay, now we're going to graph a couple of these. First one, y equals 4 sine 2 times x minus pi over 4. We want the vertical displacement. Displacement, that's the d value we're looking for. Well, the d value goes over here and there is nothing, so there's no vertical displacement. So already, you know what that means? That means we have the midline right along the x-axis. Amplitude. Amplitude is the a value, and the a value is 4. So our amplitude is 4. So what we could do right now is put our maximum and minimum line. This is what I like to do. 1, 2, 3, 4, and I'm going to put my maximum line right there. And -1, -2, -3, -4, I'm going to put my minimum line right there. So my whole graph should fit in between these two dotted lines, the top one and the bottom one, should fit in between there. Period. Well, period equals 2 pi over the absolute value of b. In this case, b is 2, so we have 2 pi over 2, which is pi. Okay, the way I do this now is I find 5 key points. The first point is going to be where it's shifted over to. So since this is negative pi over 4, the graph has been shifted over to pi over 4. The way you would get the last point is you would add on the period. So if I add pi onto pi over 4, pi is the same as 4 pi over 4, I'd end up with 5 pi over 4. And then what we have to do is you have to figure out how much to go up by every time. The way you do that, you'll see you have to go up once, twice, 3 times, 4 times. So you have to take the period and divide it by 4. Well, pi divided by 4 is pi over 4. So pi over 4 plus pi over 4 is 2 pi over 4, which is the same as pi over 2. 2 pi over 4 plus pi over 4 is 3 pi over 4. Add another pi over 4, you get 4 pi over 4, which is the same as pi, and add another pi over 4 to 4 pi over 4, you get 5 pi over 4. 5 pi over 4. So it worked. Okay, so let's put these points on our graph. I think I'll go 2 steps. So this is pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4. Could keep going. Next would be 6 pi over 4, which is 3 pi over 2. Next would be 7 pi over 4. And next would be 8 pi over 4, which is 2 pi. That's a nice place to stop. Okay, we're almost done. All we have to look at now is what kind of graph is this? It's a sine graph. Where do sine graphs start? They start at the midline. So we're going to go to the midline, and it starts at pi over 4. And our next key points, our 5 points, were pi over 2. Well, sine graphs go up. Then they go back down to the midline at 3 pi over 4. Then they go down to the minimum at pi. Then it goes back to the midline at 5 pi over 4. So we're finished. If you want, you could keep going back up to a maximum, midpoint, minimum. Could also continue it this way. Minimum, midpoint. This would be at negative pi over 4. So now we just need to draw the thing. Okay, excuse me for the sloppiness, but there you go. One more of these. I like these questions, so we'll do one more. For my sake, I enjoy them. Vertical displacement, that's the d value, it is 1. So I'll put 1, and I can put my midpoint right away at 1. Amplitude, that's the absolute value of a, so the absolute value of negative 2, which means it's 2. So that means our maximum value is going to be 2 more than this, up here, and our minimum value is going to be 2 less, so right here. So midpoint's at 1, maximum's at 3, minimum's at negative 1. Period is 2 pi over the absolute value of b, and b is pi over 4. So we've got 2 pi. I'm going to put the 2 pi over 1. We're going to divide by pi over 4. That's the same as multiplying by the reciprocal, 4 over pi. So look, we can cancel out these pi's. We're left with 8. I know that's a weird value. Usually we have pi's and stuff, but hey, it's kind of nice just to have a period of 8. Got to find our 5 points. Well, to get the 5 points, we need to find the first point by looking at the phase shift. Since this is plus 3, it means it's been shifted over to minus 3. The last of the 5 points, you're going to add on your 8, the period, so you end up with negative 3 plus 8 is 5. And then to figure out how much to go up every time, you take 8, the period, and divide by 4. You get 2. Negative 3 plus 2, negative 1. Negative 1 plus 2, 1. 1 plus 2, 3. 3 plus 2, 5. Great, it worked out, and we can put our points. Oh no, we have a big problem here. This line here should not be here. Give me a second, I gotta fix stuff. Okay, we're getting rid of this whole part of the graph here. I moved my y-axis over here, sorry, and now I've set it all up. So yeah, sorry about the big mess. Now, this is a cosine graph, and it's a negative cosine graph, so you have to be especially careful here. Remember how usually what cosine graphs do is they start at a maximum and they go down like this, right? But if it's a negative cosine graph, it won't start at a maximum, it'll start at a minimum, and it will move up. So it's going to go something like this. So this is what we have to do. At the first point, which is at negative 3, we're going to start at the minimum. So at negative 3, we're starting at the minimum, which is right here. Remember, this is our minimum line, this is our maximum line, this is our midpoint line. And then the next important point is negative 1. That's where it'll be at the midpoint. Next important point is 1. That's where it'll be at the maximum. Next important point is 3. That's where it'll be back at the midpoint. Next important point is 5, and I'll be back at the minimum. So you end up with this very stretched, horizontally stretched graph that looks something like this. And with that, we are finished our review of trigonometry. Now, if I've timed this right, it is now spring break. Congratulations. Enjoy it. It's going to be awesome. 2 weeks off. I love it. You love it. But if you're finding any of this trigonometry stuff difficult, your task over spring break is to brush up on it, especially the stuff in the first 2 reviews, because the next chapter is really, really hard. Enjoy the break.
I'll take you